Hey guys, so we're gonna be doing 9.45 today. Okay, so we're trying to find the current in. We're trying to find the current on the right hand side. Okay. So first thing we do when we're trying to find I naught, because it's a big I, so we know that that's gonna be our phasor value. So it's gonna look something like x angle y, right? So initially my thought was, let's do source transformation right here, but you can't do source transformation when you have a resistor and a current source. It's the resistor and voltage source in series. Then you can do, or here, I'll draw it. It's like you have this, and then if you wanted to do a source transformation, you would have this, right? So I just got those two mixed up. And then the next thing that came to my mind was, why don't we just close off this whole right hand side, and then eventually we'll be left with the circuit that is like this. So if we just simplify this down, we'll have like whatever, I don't know, call this like Z right hand side, whatever. We're gonna find the current that goes, we could find the current that goes right here, right? And then once we got the current that goes right there, then we could just keep splitting it up and do CDR, current division rule, right, to find the some that goes down here, right, and then some goes like right here, right, and then after we had found the current that goes right here, then we'd have to just split it up one more time to do that. I didn't really want to do all that just because I don't like redrawing all the circuits, and I think it just takes too long, and especially on the test, like, you know, you don't have unlimited time, like everything is a trade-off. So I thought, let's do mesh analysis, but I was getting a weird error, but I'm just bad at math, so let's do mesh analysis because it works. So right hand mesh, for mesh analysis, we have to define the meshes going in the same direction. So for this one, I defined them going clockwise. It doesn't matter, but I just chose clockwise because that's the direction that the current source is going in. And more importantly, that's the direction that the variable we're solving for is going, right? It's going clockwise. So it's usually good to make whatever you're solving for, or define the direction of your current for your mesh analysis, going the same direction as the element that you're solving for. So because I naught goes down this way, I made all of mine clockwise, just because whenever I solve for I3, then I know that since I made it the same direction, I won't have to switch the sign at the end. So, right, because if I had made it going the other way, this way, that actually goes the opposite way of I naught. So at the end, whenever I'd solve for I3, then I would have to multiply it by -1 or switch the sign. Kind of important. Okay, yeah, so do the analysis for mesh 1, right? So we have this element and then this element. We get this down here. Initially I was gonna plug them into initially I was gonna back substitute them, but then for the second mesh, you didn't even have to back substitute, because right here, after we had done, actually let's do the second mesh. Okay, second mesh, so we got J4 right here, right? Right up here, J4, and we got this one, I2 minus I3, right, which is right here. Except for I3, I just switched it with I naught because they're the same thing. And then we have this one on the left hand side, so minus J2, I2 minus I3, but I3 is just 5 because we know that the current for this entire mesh is going to be 5, so it's 5. So my initial plan was to do back substitution, so substitute this into like this little red squiggly you see over here, but it all canceled out anyway, so then I was left with I naught J2, and I had a minus right here, so I was wondering why that's wrong. It's actually plus, just I messed up on the sign errors. Anyways, so we have I naught equals J2 over J10, and then I naught equals minus 5 amps. And then that's the answer. So you actually didn't even have to do the analysis for mesh 3, but it is important because when we go back or you should still do mesh 3 just because you can use this mesh to check your work. So whatever you got for I naught and then whatever you got for I2, I didn't finish calculating this, but they should be the same value in this equation. And then if they're not, then you know that you messed up. If you found this video helpful, then do all that helpful stuff. Unsubscribe, leave hate messages, all that good stuff.